Okay, ladies and gentlemen, this is your well-rounded math teacher, Mr. Pickar, and I want to go over the Unit 1 quiz review so you can take your Unit 1 quiz. This first problem here, number 1, deals with 4 graphs, and you want to match it up with any one of these, what we got here, ordered pairs basically is what they are. So let's go to the first one here. My first ordered pair right here is 1, 10. Make that a little smaller. Second one looks like it's 2, 7. And then we got 3, 4. And 4. That point right there is 1. Okay? So matching that up, it looks like 10, 7, 4, 1. It looks like it would be D right here. So we're going to go over here and say this is D. Now this is definitely a linear one. So we're going to use y equals mx plus b, slope-intercept form. Now what is it changing by? Well, it looks like it's going down 3 each time. So that would be my slope. M equals -3. The y-intercept here, remember, is the term before your first term. So going backwards here, okay, right here, that'd be 0. Well, instead of subtracting 3, I'd add 3. That'd be 13. So 0, 13. So this would become y equals -3x plus 13. Okay, let's go on to the next one here. Generate our ordered pairs. Our first ordered pair right here is 1. Looks like it is 12. Make sure that's right, yeah. 1, 12. Next one is 2, 6, yeah, 2, 6. I can't see that very well. Then we got 3, 3, and then it's 4, and I'm not really sure what that one is, but I got 12, 6, and 3. So I'm going to go over here. I got 12, 6, and 3, so this one is B. Anyway, this is not linear. This is more of a curve, and if you look at it, we're not adding the same thing, or in this case, subtracting the same thing. Here it's a difference of 6. Here it's a difference of 3. It looks like we're multiplying. So what are we multiplying by? Well, it looks like you're dividing by 2, actually. So the deal is, if you're dividing by 2, you're actually multiplying by 1/2. So when we write a formula for this one, we're going to say y is equal to, in this case, what would you do with the first term, 12? What you're multiplying by is 1/2. And this would be, if you start with the first term, you got to say x minus 1. If you started with the second term, you'd say x minus 2. You could go with the term before that and kind of keep it similar to our linear equation. That would be 0, and this would be 24. And the reason it would be 0, 24 is, well, if you're multiplying by 1/2 going down, you would multiply by, well, divide by 1/2, and 12 divided by 1/2 is 24 times by 2. So you could also go with the original term before that and go with 24 times 1/2 to the x power. So you could use either one of these for that. This is the first term, you got to say x minus 1. This is the term before the first term, you can just go with x. Okay. So this one, our ordered pairs, looks like the first one is 1, 3. No, it's 1, 2. Second pair right here is 2, 4. third one looks like it's 3, 8. And then this one is 4, 16. So once again, it's not linear. This is geometric. And it looks like from 2 to 4, it looks like you're multiplying by 2. 4 to 8, once again, multiplying by 2. So the formula, one of the formulas you could use for this, if you're using the first term, that would be 2, and we're multiplying by 2, and that's the x minus 1. So if you're using the first term, it's x minus 1. If you want to use the term before that, well, that would be 0, the initial term. Instead of multiplying by 2, I'd divide by 2. I'd get 1 there. So you could go with y equals 1 times 2, and that would be to the x power then. And that's the term before the first term. So some people like to use this form. Some people like to use this form for your geometric. What do we got here? 2, 4, 8, 16. That looks like it is C, by the way. Forgot about that. That's C. Okay, this one's definitely linear. Looks like the first term is 1, 3. Second term here is 1, 6. Okay, second term, sorry about that. That's 2, 6. Third term, 3, 9, and then 4, 12. So we're going up by 3. We're adding 3 every time. So my equation for this just going to be in slope-intercept form. Y equals mx plus b. My change is 3, so that's 3x. Plus b, well, that's the a sub 0. So it's going to be 0. Instead of adding 3, you'd subtract 3. So 3 minus 3 is 0. So you could just say y equals 3x. Okay, so that's the first problem there. Kind of deciding if they're geometric or arithmetic. And this one, 3, 6, 9, 12, I think that was, yeah, A. That one's A. Okay, so let's go to number 2 here. Yeah. My first term, a sub 1 is negative 9, and then it goes to 4, and then it goes to 17. So the first thing you got to decide, am I multiplying or am I adding? Well, 4 minus 17 is 13, and 4 minus negative 9 is 13. So it looks like we're adding 13 every time. So it says find that 22nd term. Well, first I'm going to do this. I'm going to put this in slope-intercept form because we're adding the same thing every time. I'm going to find a sub 0 here. So instead of adding 13, to go backwards, I'd subtract 13. So that's negative 9 minus 13. If you plug that into your calculator, you should get negative 22. So that's kind of like my b or my y-intercept. So my equation is going to be 13x, because we're adding 13 every time, and my y-intercept is negative 22. So I'm just going to write minus 22 there. So y equals, if I want to find the 22nd term, just plug in 22 for x. So that's 13 times 22 minus 22. If you plug that into your calculator, you should get 264. So my 22nd term is 264. Now, it says, is 507 a term in the sequence? Well, that means is one of my y values equal to 507. So plug 507 in for y. 13x minus 22. And see if it's true, or a whole number. If it's a whole number, well, then it's one of my terms if I solve for x. So I'm going to add 22 to both sides and get 529 equals 13x. These cancel out. Divide both sides by 13. And I get this, x equals 40.69. The decimal keeps going. So it's not a whole number. So the answer to this question would be no. If I would have got 40 exactly, yes, it would be then. It says find the sum of the first 22 terms. Okay, so this is our series formula. When we add up all the terms, that's S sub n. That means we're doing a sum. N over 2 times a sub 1 plus a sub n. So my first term, remember that's my first term. And a sub n is my last term. And then n is just the number of terms. So first 22 terms, that means n is equal to 22. A sub 1 was my first term. I think that was -9. A sub n is the last term. And we found the last term, or the 22nd term, to be 264. So what do we got here? S sub n, the sum. They call it a series, but anytime you want to add up all terms, it's a sum. N is 22, so 22 over 2, -9 plus 264. Okay, I think I gotta do that quick. 11 times, whatever, -9 plus 264. That's 255. And then just multiply 11 times 255. 2805. So the sum of all those terms is 2,805. Okay. What we got here? Let a sub 1 equal 5. Then the sequence goes 5, 15, 45. Find the 12th term. Is it arithmetic or geometric? Well, looks like here I would add 10. Well, 15 plus 10 is 25, so it's not arithmetic. You're not adding the same thing every time. So I just take 45 and divide it by 15, and then that is 3. Is 15 divided by 5 equal to 3? Yes. So it looks like I'm multiplying by 3 every time. So that's what I'm doing. Multiplying by 3. Let's go right here. So it says find the 12th term. So you can do it one of two ways. The first way would be this. If I'm using the first term 5, it's going to be y equals 5 times 3 to the x minus 1. Well, if I want to find the 12th term, that's 5 times 3 to the 12 minus 1 power, or 5 times 3 to the 11th power. If you plug this into your calculator, it's 5 times 3 in parentheses. Just use the caret key, 11, and you should come up with 885,735. Okay? If you don't like to do it that way, if you want to use the term before this, now instead of multiplying by 3, you'd have to divide by 3. So the term before 5, your first term, or your a sub 0 term now, would be 5 divided by 3. So if you do it this way, don't use the first term, so it wouldn't be x minus 1. Make sure you put 5/3 in parentheses. We're still multiplying by 3, and it would be to the x power. So this is 5 divided by 3 times 3. Make sure that's in parentheses too. And we're going to find the 12th term. When you plug this into your calculator, you're still going to get 885,735. Okay, so you can do it this way, or you can do it this way. Is 3,645 a term in the sequence? Well, this one you can't really solve like a linear equation when you're multiplying like this. You just kind of find the whatever term it is. So it's less than this, so it's definitely going to be less than 12. You could just start doing this, and I'm just going to do 5 times 3. Oh, let's try the fourth. So 4 minus 1. If you plug that into your calculator, that'd be 5 times 3 to the third power. I get 135. So it's not even close. So I would just keep going like this, and I think when I got to the 5 times 3 to the fifth, 5 minus 1, 5 times 3 to the 6 minus 1. I think when I actually got to 5 times 3 to the 7 minus 1 power, that's 5 times 3. You just got to kind of plug this into your calculator and try it. 7 minus 1 is 6. Let's see what I got. Yeah, I get this. 3,645. So it is the 7th term in this sequence, so it does actually fit in there. So we're good to go there. Find the sum of the numbers 101 to 500. So it's 101, 102, 103, all the way up to 500. So this is a sum again now. So we're using this formula. S sub n equals n over 2 times a sub 1 plus a sub n. Now, what is n? We'll get to that in a minute. A sub 1 is 101. A sub n is the last term. That's 500. Well, how many terms are there? Well, if you did how many terms 1 through 10, everyone would say there's 10 terms. Okay, but if you subtract those to find out how many terms there actually are, 10 minus 1 is 9. You have to add 1 because you're really getting rid of that 1. So that's 10 terms. So if I take 500 and subtract 101 from it, I get 399. So a lot of people say n is 399, but you're getting rid of the 101 when you subtract 101. So you got to add 1. So there's really 400 terms. So that means n equals 400. So plugging everything in, there's 400 terms. A sub 1 is 101 plus 500. So that's 200. 400 divided by 2 is 200. I get 601. And when I multiply these two, what do I get? 120,200. So make sure you plug that into your calculator and make sure it works out. Okay. So let's go to the 9th term of the sequence is 117. The 12th term is 159. How is the sequence changing from one term to the next? Okay, so the best way to do this is just kind of list them out. The 9th term. Well, let's start out with the first term, 2nd term, 3rd term, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th. And I know the 12th term is 159. And the 9th term is 117. So how is it changing? How is it going up? Well, the best way to do that is take 159 and subtract 117 from it. When you take 159 and subtract 117, you get 42. Well, I'm going to have to add 1, 2, 3 numbers to get to 159. So I'm going to take 42 and divide it by 3. And 42 divided by 3 is 14. So just add 14. 117 plus 14 on your calculator is 131, just to make sure this works. If I add 14 again, plus 14, if I add 14 again right here, 14, I'm going to get 145. And if I add 14 again, 14 plus 145 is 159. So it is changing by 14 every time. So 117 minus 114 is 103. Minus 103 minus 14 is 89. Minus 14 is 75. And you can go back and check your work later. 61, 47, sorry, 33, 19. So my first term would be 5. 5 plus 14 is 19. You gotta kind of go right on down the line. So it says find the first term and use that to find the sum of the first 12 terms. Well, we just found the first term right there. A sub 1 equals 5. The 12th term is 159. We knew that. So that's my last term. A sub n equals 159. And well, we're finding the first 12 terms. And it says find the sum. So we're using that S sub n formula, the sum formula, n over 2 a sub 1 plus a sub n. 12 terms, so 12 over 2, a sub 1 is 5, plus 159. If you plug this into your calculator, you should get a grand total of 984. So make sure you add these two. 12 divided by 2 is 6, so 6 times whatever that number is, and it is 984. A house for a price of $200,000 increases by 4% each year. That means your multiplier, they give us the multiplier here, is 104. The value of the home after 1 year is $208,000. After 2 years, it's $216,312. And you get this by just multiplying by 1.04. So after 1 year, it's $208,000. After 2 years, it's $216,320. And you could do 3, 4, 5. You're just multiplying each time by 1.04. Or we could use this formula. We could use one of two formulas. Now, this is like your a sub 0, the original term here. So we're going to do this. I'm going to give you two formulas. If you use the first term, it's going to be y equals 208,000 times your multiplier 1.04 to the x minus 1. So that's 208,000 times 1.04. Well, x minus 1, well, we want to find how much a house is worth after 10 years. So we're going to plug 10 in here, 10 minus 1. And let me plug that in real quick. 208,000, parentheses 1.04, and then the caret key. 10 minus 1 is 9, so I'd hit 9. And I get 296,048.857. So we got to round this to the nearest cent, so that's 296,048. And this would be, if you round it up, that'd be 86 cents. Now, you could do it this way also, if you don't use the first term. If you use that initial term, you could just do y equals 200,000. 1.04 is our multiplier to the x. So 200,000, 1.04 to the 10th. And you're still going to get the same thing. $296,048.86. Okay? An iPad purchased for $600 depreciates in value each year. After the first year, the iPad is worth $486. After the second year, the iPad's worth $393. Hold on here. $393.66. What is our multiplier? How much is the iPad worth after 5 years? Hint, how is the figure out how it is changing? What is it being multiplied by? Well, to figure out what it's being multiplied by, you got to do this. Take 393.66 and divide it by the term was previously worth, which is $486. So 393.66 divided by 486, that's 0.81. 0.81. So this is going down. It's going down about 19% a year. So we're just multiplying by 0.81. So a couple things we could do here, and you could check this work by taking 486 and dividing it by 600. 486 divided by 600. Let me do that quick. Yeah, and I get the same thing, 0.81. So my multiplier is 0.81. So we're going to do this. We're going to multiply by 0.81. If I use the first term, I'm going to have to use that formula, y equals 486 times 0.81 to the x minus 1 power. Or if I want to go with the term before that, 0, which is 600, I could do y equals 600 times 0.81 to the x. Either way, you're going to get the right answer. It's 5 years, so if I just use this second formula I did here, it'd be 600, 0.81 to the 5th power. And if I do that, caret key 5, I get, in 5 years, it'll be worth $209, and if you round it, 21 cents. Yeah. Here, if you did it, I'll do it in red here so we don't get it confused. If you go with that first term, you got to subtract 1. If you went with the third term, you'd have to subtract 3 from x. 486 times 0.81 to the 5 minus 1, well, that would be 4. So it's 486 to 0.81 times 4, and you still get 209.21. Okay, what we got here for the last problem? In order to get to know each other better, a class plays a game where the first person states their name and the second person states their name and the person before them. So if it's like me, I'd say, hey, my name is Mr. Pickar, and then Johnny goes next. He'd say, my name is Johnny, and the person before me was Mr. Pickar. And the third person would say is Sue. Sue says, my name is Sue. Before me was Johnny, and before Johnny was Mr. Pickar. So she'd say 3 names. So me, the first person, I'd say 1 name. Johnny says his name and my name. He says 2 names. The third person says 3 names. The fourth person says 4 names. And this goes on until you get to the 20th person. The 20th person, guess what? They're going to say 20 names. Okay? So that's kind of how this works. And the names before them. This continues for 20 classmates. How many times are the names stated? So we want to add up all the names that were stated. So if I say 1, Johnny says 2, so on and so forth, we're adding up all these names. So we're going to use that sum formula. N over 2 times a sub 1 plus a sub n. Well, how many people are saying names? Well, there's 20 altogether, so n is your 20. That's the total number of times we're doing this. But each person says so many names. The first person says 1 name. The last person, a sub n, would say 20 names. So plugging everything in here and adding up all the names that were said. My name was said 20 times. Johnny's name was said 19 times, so on and so forth. It would be, well, there's 20 people doing this. A sub 1 is 1. A sub n is 20. So this is 20 divided by 2 is 10 times 1 plus 20 is 21. If you multiply this, 210 names were said in this little activity where we're trying to get to know everyone's names. So that's the review. A lot of problems are very similar to this. You should be able to follow this review, your review worksheet along, and do pretty good on your quiz. The last couple problems, you're gonna have to do some thinking. Just do your best. If you at least try them, you're gonna get points for it. Like if it's out of 3 points, if you at least try it and you make a little mistake, you'll get 2 out of 3 or 2.5 out of 3, whatever it is. So I just want you to try them, do your best. If you do have questions, you distance learners, send me a message and I can do a Google Meet with you and we'll figure it out. So that is it. Good luck on your quiz. Try and get that done before Thursday. I'm gonna put into the books on Friday. Like I said, if you have questions or you need help with the quiz, use your review sheet or send me a message and I can maybe help you out in a Google Meet. Have a great week.